Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the PSSA big ideas, this time on simplifying expressions, specifically algebraic expressions, which I could have put in the title, to be quite honest with you. And this is going to be all about the distributive property and like terms. So what is the distributive property? Well, you can take a look at this as I read it out loud to you. It says that whenever you have an addition or subtraction problem, usually written in parentheses, and then it's being multiplied by a number, then here's what you can do. You can multiply each term of that addition or subtraction problem by the multiplier that is sitting outside of the parentheses. And that's what we can have here. I showed it first algebraically. The multiplier is a, and what you can do is you can multiply it to both terms of the sum. A times b, which is ab, a times c, which is ac. Now, looking at something a little bit more practical with numbers and variables mixed together, here we have 4. And the 4 is the multiplier. I know that it's the multiplier because it's right next to the parentheses with nothing in between. And there is addition inside of the parentheses. So what you can do is you can take the 4 times the 3n and the 4 times the 5, and that would give you 12n and 20. Notice the addition stays in between. Now, do you necessarily have to show the step where I put 4 times dot 3n, 4 times dot 5? No, you probably don't have to anymore because this is not the first time that you've ever seen the distributive property. This is naturally a review. So you could probably skip that in-between step and go straight to the 12n plus 20. Which brings up the next idea we have to talk about, which is like terms. Terms, what are like terms? They are terms that have the same exact variable, or possibly the same exact multiple variables, or possibly no variable at all on both terms. Either way, that's what we call like terms, terms with the exact same variable or no variables at all. Why does this matter? Because you can add or subtract like terms together. You cannot add or subtract unlike terms together. So, for example, 18n plus 4n is allowed to simplify to become 22n. Why? Because they both were like terms. They both had the same exact variable, this case being n. But in contrast to that, 18n plus 4, it cannot be simplified to 24n. Why? Because they are not like terms. They are unlike terms. Why are they unlike terms? Because the 18 has an n, but the 4 does not have an n. This is why they are not like terms, and therefore they cannot be added together. This is something that is always true in math. You are only allowed to add or subtract things together when they are like terms. However, I do want to point something out to you. Multiplication and division do not apply to the same rules when it comes to like terms. Things do not have to be alike to multiply or to divide. You will notice I did take 4 times 3n and got 12n over there on the left side of my screen. You're like, well, they weren't like terms. They don't have to be to multiply. The only time you have to have like terms in order to do the mathematical operation is when it's addition or subtraction. Speaking of subtraction, there is a very special thing that we learned earlier this school year on subtracting linear expressions. Follow along with me here. When you subtract by an addition or subtraction expression that is written in parentheses, then what you can do is what a lot of mathematicians call distribute the minus to each term that comes next, that's being subtracted, of that expression. So, for example, we are subtracting by 3x plus 7. So what you can do here is you can distribute the minus. It's kind of like distributing a negative. And you would say, what's a negative times a positive 3x? Well, that would be a negative 3x, although I'm going to write it as minus 3x. What's a negative times a positive 7? Well, that would be a negative 7, and so you'll notice I made it minus 7. Now, I'm going to be honest with you. I didn't really teach it to you that way earlier this year in pre-algebra. The way that I taught it to you, if you recall, was to make subtraction adding the opposite and then to distribute the negative to both terms in the next expression. If that makes more sense to you, then you can definitely do it that way. Then you would have a negative 3x, and you would have plus negative here. And then you would have a plus negative 7, because a negative distributed to the 7 makes it negative 7. If that makes more sense to you, you definitely are allowed to do it that way. But I'm not going to lie to you. In Algebra 1, you will probably distribute the minus instead of making it plus negative and distributing the negative. It really is the same idea, though. Likewise down here, if we distribute the minus, then you would ask yourself, what is a negative times a positive 5x? And that would be a negative. What's a negative times a negative 8? Because it's a minus 8. So think a negative times a negative, and that would give you a positive 8. Again, if this is not making perfect sense to you, maybe you would prefer to make the subtraction become adding the opposite, and you'd probably do it inside here as well, then distribute the negative to the 5x, and that would make it negative 5x, and then distribute the negative to the negative 8, and that would make it a positive 8, as you can see right here. There's no sign on that, so that's a positive 8. So it's up to you if you want to make the subtraction in between the parentheses become adding the opposite and then distribute it, or just distribute the minus, as you would probably be taught by an algebra teacher. Either way will work. All right. Last thing on this page is a review on simplifying algebraic expression. This is kind of a review of what we were talking about at the top of the page, but putting it together. What you would need to do is use the distributive property first at any place where it could be done. Again, we're looking for a multiplier being multiplied in parentheses with addition or subtraction inside of the parentheses. After you do the distributive property, then step 2, then you would add or subtract the like terms together. A lot of kids want to skip step 1 and want to go straight to adding like terms. You cannot do that. You have to do the distributive property first. So on this example, if you would try to do the 3n plus 16n and make 19n, no. The 3n is in parentheses, and outside of the parentheses is a multiplier. You must distribute that multiplier. 4 times 3n, 12n. 4 times 5, 20. That is the distributive property, and you got to do that first. Then you can add the like terms together. And it just so happens that on this problem, the like terms are the 12n and the 16n, which of course would give you 28n. You would not add it to 20 and get 48n because the 20 does not have an n, and therefore you no longer have like terms that you can add together. All right, now that we've done that review, I would like for you to try 3 problems here on your own. Write them down on a separate sheet of paper, hit pause on the video, do these 3 problems, then hit play when you're ready to see how you did. Okay, I hope you've already done numbers 1, 2, and 3 on your own. Let's see how you did. Problem number 1. We have like terms, 4y and 12y, but we cannot use the commutative property and switch the order when there is minus. So, hopefully, you made the subtraction become adding the opposite and then switched the order. Now, in Algebra 1, you might not make the subtraction adding the opposite. You might switch the order, but keeping the minus with the 12y whenever you switch the order. That's kind of an alternate way of realizing that minus is the same as adding a negative and then switching the order. So you might do it a little bit different in your Algebra 1 class than what I'm showing you here at the pre-algebra level or Math Grade 7 level. But anyway, the negative must stay with the 12y. 4y and negative 12y, they are the like terms. That's going to give you negative 8y because a positive plus a negative, you subtract in your head, and we still have plus 10w. Notice the 10 has a w, the negative 8 has a y. They are not the same variable, so they are not like terms. So that's as far as you can go. Problem number 2, we have subtraction, make it adding the opposite. We also have subtraction on the minus 10, make that adding the opposite, and then you are going to distribute the multiplier. The multiplier here is the 12. Sorry, not the 12, the negative 12. So the negative 12 will get multiplied to 3x and multiplied to the negative 10. Negative 12 times 3x is negative 36x. Negative 12 times negative 10 is a positive 120. If you did not make subtraction adding the opposite, you probably accidentally had a minus 120, which would have been wrong. This is why I highly recommend making subtraction, become adding the opposite, so that way you realize that you were not really distributing a positive 12, you were distributing a negative 12. Now, the x that was on the far left of this expression, it is like terms with the negative 36x. But how much x is that x? It is 1x. Positive plus a negative. Subtract in your head. You will get negative 35x plus 120. And that's as far as you can go because they are not like terms. Problem number 3. All right, I'm not sure which way you wanted to do number 3. Did you think of it as distributing the minus? Or did you want to make the minus become adding the opposite and then distribute the negative? It really will do the exact same thing, whichever way you decided to do that. So a negative times a positive would give you a negative 4n. A negative times a negative 17 would make it plus 17. Now, if it's too weird for you to think of minuses as negatives, then what you could have done is you could have made the subtraction become adding the opposite here, and then also adding the opposite. Oh, I need another plus negative. I'll steal one from over here. Make it adding the opposite here. Then you could distribute the negative to both terms in the next set of the parentheses. So the negative gets distributed to the 4n and to the negative 17. And then a negative times a positive 4n would make it plus negative 4n. And then also the negative distributed to the negative 17 would make it a positive 17 because the negative times the negative is a positive. Then you can use the commutative property, switch the order, and then you would finally add your like terms. 19n and negative 4n makes 15n, 1 and 17 would make 18. All right, let's do a much more interesting problem. Let's throw in the idea of perimeter. Perimeter of a square is 28x minus 4. What is the length of one side of the square? Well, I hope you remember what perimeter means. Perimeter is not area. This is not the idea of length times width. Perimeter is the distance around a shape. So, with that in mind, and yes, this does, believe it or not, tie in with either like terms or the distributive property, try this problem on your own. So hit pause in the video, try it on your own, then hit play when you're ready to see how you did. All right, I hope you've already done this problem on your own. The unique thing about a square is that all four sides are congruent. That's what these little slash marks are supposed to show you, that they are congruent sides. So if all four sides are congruent, then what you could really do is just take the perimeter and divide by 4. But if you do that, you need to use the distributive property. Think of this as something in parentheses. Divide them both by 4. So you're going to divide by 4 to the 28x, and you're going to divide by 4 to the minus 4. And that would give you 7x minus 1, which is choice B. Now, another way of thinking of this is that the length of the side times 4 should give you the perimeter. And so again, you would use the distributive property. 4 times 7x, 28x. 4 times minus 1 is minus 4, which confirms that 7x minus 1, which was the side length, actually does give you the perimeter that we had on the original problem. So, two different ways of thinking of it, but this is how this would work for a perimeter of a square, where all four sides are congruent. All right, let's do another multiple choice problem. This one is not geometry related. It just says which expression is equivalent to 3.5x plus 4.8. Hit pause on the video, try this problem on your own, then hit play when you're ready to see how you did. All right, I hope you've already tried this on your own. Let's see how you did. Is the answer choice A? Well, choice A says 3 times 0.5x. If you take 3 times 0.5x, that would give you 1.5x. Well, that's not what the original problem had. Furthermore, if you take 4 times 0.8, that would not be 4.8. That would be, what, 3.2? So choice A, goodbye, you are not correct. Is it choice B? Again, we have the problem here. 3 times 0.5 is 1.5. It's not 3.5. And this one's even worse because x times x would not be x. It would be x to the second power because that's what x to the second power means, x times x. So that is totally not what the original expression was. And again, 4 times 0.8 would be 3.2, which is not the same as 4.8. So goodbye, choice B. You are completely wrong. So we're down to choice C and choice D, and they look really, really, really similar. But there's a big difference. Choice C just has 3. Choice D has 3x. You are only allowed to add or subtract when you have things alike. Think like terms. 3x plus 0.5x would make 3.5x. You cannot add 3 to a 0.5x when the 3 does not have an x. This is why choice C is no good. It is choice D that is the correct answer to this problem. Oh, and 4 plus 0.8 is 4.8. I should have mentioned that as well. All right, so that concludes the video I'm going to do here. The second page that I tied in with simplifying expressions on solving equations and inequalities. I'm going to do that in a separate video because this might be longer than what a full day could actually handle. So we're going to stop this video for now. Thank you for watching. We'll see you next time.